So, in this week, let us first discuss the homework problem of work train. So, the first homework problem where we are supposed to predict how the experimental UV visible spectra for this molecule will look like. These are azobenzene derivatives, and E and Z, there are two possible isomers. The geometries are there in this link. So, this E and Z, you see there are two different colors. It is just to mention the colors of the compounds itself. So, the E isomer colors red and the Z isomer actually colors yellow. Now, so let us now do the calculations. I already have the XYZ file here, the Z isomer and the E isomer. Here is the isomer. So, let us start with the E isomer. Let us go to Avogadro, go to extension, generate Orca input file. And also let me generate the Z isomer. I go to the extension, Orca, generate Orca input file, and generate inside this one Z isomer. Now, if I run this to calculation, although I am using Rij cos x, I have asked for 30 roots, and this actually takes a lot of time. So, I have already run it beforehand, and I will open the files one by one. First open it notepad. So, okay, first thing is to see how much time it has taken. It is almost half an hour. It has took this calculation. I did it in the same laptop only. So, here are 30 roots what we have calculated, and let's now open it with ChemCraft and see how the spectra looks like, because that is what we wanted to predict. So, TD spectrum by electric dipole moment. So, if I plot it with respect to the transition dipole moment, you see the lowest energy transition actually happens around 480 nanometer. Although there are, because remember I am talking of the wavelength scale, so right hand side is low energy. So, this 480 nanometers, 490 almost. So, this will look like an orange color mix between red and yellow, and so the complementary color will be, because remember whatever is absorbed, the complementary color is shown. So, the complementary color will be red in this case, whereas in the let us see now the output file for Z isomer. Tools, so TD spectrum by transition electric dipole moment, and let me broaden the bands. So, you can play with the full width half maxima. So, you see the lowest energy transition is around 390 parameter. That's in the previous one. In the other one, it's around 490, and this one, the E1 is around 490, the Z1 is around, open the Z isomer again, you can also try to visualize the UV visual spectra in Chemirax, but the Avogadro may not be able to plot the UV visible spectra. So, it is around 380, 390 nanometer. So, the color will be, the absorbed color will be green, and the complementary color is yellow. So, this is what the colors actually looks like. So, by doing this you can actually plot this spectra, you can use the Gaussian broadening, you can do the different this one, you can import the values from other thing also and plot it. So, this kind of things you can done, and you can actually export these values and actually put it into some graphical plotting program and then plot the actual spectra. Remember always that to make production quality, although this looks not bad, but to make production quality data, it is always advisable to use a dedicated plotting software like GraphPad X or Origin like that, or GNU Plot. GNU Plot is free actually. So, you should use a specialized plotting software. So, you take the data from here and then plot it into in a dedicated software, so that you can actually, because you can take these data from here and you can actually export these values. Like here all these values were given, like what is used for plotting the spectra, all these values are given here. So, you can go to the export value, copy it and put it in a graph plotting software, so that it gives you much better resolution pictures out of it. So, this was my first homework problem. My second homework problem is to optimize the first optimized state of DMA-BN. So, let me make the geometry. Again, to make the geometry, it will be easier to make it in Avogadro. You may have seen that we are using Avogadro and Chemcraft almost interchangeably, but it depends upon which one you are more comfortable at. I sometimes feel more comfortable in Avogadro, sometimes feel more comfortable in Chemcraft. So, I just use them interchangeably. So, to draw DMBN, we have to first need a benzene ring. So, I go to build, insert, fragments, aromatics, nice. Go to the benzene. Now, I put the I replace one of the nitrogen, this one, and each of the hydrogen now I will replace by a methyl group. So, next I will put a carbon there without adjusting the hydrogens, and then I will put a nitrogen double bonded again without adjusting the hydrogen. So, my DMBN structure is fine. So, the first thing to optimize it to the excited state, first we need to optimize it to the ground state. So, let us do the first thing first. So, we will do a two state optimization first. Of course, we are going to use a force field optimization. Then generally it is a good idea to optimize once it in the ground state before proceeding to the excited state optimization. So, the ground state optimization, and you can use the ground state optimization even in a cheaper method. So, we are just going to use a RHF, but we need to use Rij cos x. BP86 can also be an option, but anyway the final optimization we are going to do in the Hartree-Fock, like CIS only, CIS has a Hartree-Fock ground state. So, we are optimizing here using Hartree-Fock. So, I open mobile stum terminal here. I think I have put a wrong name. So, let me rename it.